Welcome back to the deep dive. If you're here with us, you value getting right to the heart of really complex issues. And today we are tackling something huge. We're taking a deep dive into what our sources are calling a structural crisis in modern military command. It's a challenge that really it questions the very foundation of warfighting. We've been looking at a set of analyses that focus on that one thing that has defined great military leaders for centuries, from, Caesar all the way to Schwarzkopf, the art of war.
That's intuition, that creative spark.
Exactly. But here's the big, really challenging idea that frames our whole discussion today. In our current technological age, that art is failing. And the reason it's failing is because the science that's supposed to support it, well, it's just not there. The cognitive genius needed for strategy is just being drowned out by logistical noise.
Just swamped.
Completely. Now, the proposed solution we're going to unpack is a systematic technical fix called digital orchestration. It's supported by this mandatory automation standard that the sources call the SpaceX Standard.
Which is a fantastic analogy we'll get into.
It really is. So our mission for this deep dive is clear. We need to understand exactly how automating the physics of the battlefield, things like fuel consumption, spectrum availability, maintenance cycles,
All the messy stuff.
all the messy, gritty stuff, how doing that through a military Internet of Things, or MIoT, can fundamentally free the commander's mind. It's about clearing the canvas so the artist can actually paint.
And that idea of clearing the canvas, of cognitive liberation, that's everything here. What's so fascinating is that the problem isn't that modern commanders are, less brilliant than their predecessors. That's not it at all. The problem is that modern warfare has introduced a set of variables that has just exponentially complicated the whole environment. It's overwhelming even the sharpest human intuition.
Right. It's a data problem, not a talent problem.
It's a massive data problem. I mean, think about the sheer complexity a commander's dealing with right now. They're not just looking at a map and worrying about troop morale anymore. They are, at the same time, managing dynamic cyber effects that are flowing in from a totally non-physical domain.
Stuff they can't even see.
Exactly. And at the same time, they have to guarantee the availability of the electromagnetic spectrum, the EMS, which is constantly being jammed and contested. Then you add in orchestrating the logistics for maybe thousands of autonomous drone swarms. And on top of all that, you have the constant grinding friction of multinational interoperability.
Just trying to get everyone on the same page.
Right. So when a human commander has to spend the majority of their brain power just processing and trying to synthesize all of those battlefield physics, they lose the cognitive bandwidth they need for the actual art of the fight. They're not strategists anymore. They become effectively reactive logistical managers.
So the argument is we're asking them to do the equivalent of, quantum physics calculations, but we've only given them an abacus. But you've only given them an abacus. They're using gut feelings for things that really should be mathematical certainty.
That's the perfect way to put it. This deep dive is absolutely not about replacing the commander with an AI or, reducing command to just a spreadsheet.
It's the opposite.
It's the complete opposite. It's about restoring that scientific foundation so the commander can actually do their real job, which is strategic judgment and the creative application of force. If you want a commander to paint their masterpiece on the battlefield, you first have to make sure the paint isn't expired, the brush is clean, and the canvas is properly stretched and mounted.
You handle the science so they can perform the art.
Precisely. We're looking at how to build that foundational data layer that transforms all this operational guesswork into what is essentially scientifically guaranteed readiness.
Okay, so let's dive into that friction. Let's really get into why this is so necessary right now. Let's unpack this. This critical failure state that the source material really goes into detail on. And that's the scientific disconnect between the two main maneuver components, air and land.
Right.
Because they operate in these totally different scientific realities, they're forced to rely on what the sources describe as just incredibly crude and inefficient ways to sync up.
And that word, crude, is exactly right. We have to start with the air component because they operate under what is, frankly, an unyielding tyranny of rigid physics. They're not managing terrain like a ground force. They are managing flow. And that flow is dictated by immutable, unchangeable physical laws.
It's all about optimization. It's a math problem.
It's pure math. The reality for the Air Operations Center, the AOC, is that an aircraft is a complex, dynamic equation. It's got very strict inputs. You have fuel burn rates that change with every shift in altitude and speed. You have non-negotiable maintenance cycles that can ground an asset with no warning and rigid time-on-station limits.
And you can't just improvise your way around those.
You can't. You can't negotiate with them. You can't wish them away. And this, right here, is the constant source of friction with the land component.
Yeah, I can see that. To a land officer who is used to, the flexibility of ground maneuver, the AOC's rigidity must seem like they just don't care about what's happening on the ground.
It looks like indifference.
Right. It looks like they're just sticking to the plan no matter what. If a ground unit gets delayed by, say, 3 hours because of an IED or a flash flood, they expect the air support to just hang around and wait.
But the air component simply cannot improvise physics. It's impossible. If that ground force is delayed, the supporting aircraft runs out of fuel. That calculation is absolute.
It's a hard stop.
It's a hard stop. The physics equation demands that you follow it. You have variables like unexpected wind, or the need for a specific non-interchangeable weapon package, or the boundaries set by legally mandated control graphics. These aren't suggestions. They are hard operational constraints. If the air component is forced to divert planned sorties or extend time on station without guaranteed tanker support, well, the entire kinetic chain could just break for hours.
So the art of the air commander is completely hemmed in by the need to respect that physics equation first and foremost.
Always. Now, contrast that with the land component. They're anchored in a completely different set of scientific truths. We're talking geology and geometry.
The realities of the ground.
Exactly. Land forces survive by achieving density. The sources call it the forward operating base, or FOB mentality.
Where MASH equals survivability.
Right. Huddled together for safety. And they survive by exploiting terrain features. Their whole logic is local, it's immediate, and it's based on human-scale proximity and what you can see with your own eyes.
So they're constantly reacting to friction on the ground that is super localized and often totally unpredictable.
Which leads to a heavy reliance on human-to-human coordination.
Radio chatter, map overlays, pointing at things.
All of which is inherently slow, and it's the first thing to fall apart in the classic fog of war. So when they need to sync up with assets outside their immediate physical world like air or cyber, they have to fall back on this thing called phasing.
And that's where we get those familiar static time blocks. H-hour, D+2, 0400, 0 ULU.
Exactly. Phasing is a crude historical approximation of synchronization. It was invented because of a lack of a real-time scientific link with other assets. Since they can't share objective data on readiness, they substitute the concept of time as a proxy for conditions.
So they just assume that if everyone agrees to start at 0600, then everyone will magically be ready to go at 0600.
A massive assumption.
An assumption that seems incredibly risky, especially in modern warfare, where the enemy is also reacting and adapting in real time.
It introduces an unacceptable level of risk. So you have one component, air, operating under the strict laws of Newtonian physics, and another, land, constrained by the hard reality of geology and frankly, the slowness of human communication.
And the friction between those two different worlds is the root of the problem.
That's the core operational problem this entire concept is trying to solve.
And that friction leads directly to this consequence of operating in what is basically a scientific vacuum. The components have to use time as their one crude synchronization tool.
It's the lowest common denominator.
And a pretty disastrous one at that.
It really is. This reliance on time, instead of on conditions, is a primary driver of mission failure, or at the very least, a huge waste of resources and cognitive energy. The catastrophic problem is this. When H-hour arrives, units feel compelled, because of doctrine, because of command pressure, to move. They move just because the clock hit the right number.
Even if the underlying conditions, the science, aren't actually right.
Not even close to right. So the land unit moves out, completely unaware that the critical jamming asset they're depending on is stuck 2 hours behind schedule.
Or the air unit executes its final bombing run, not knowing that the ground objective shifted 5 minutes ago because of enemy contact, creating a massive friendly fire risk.
Precisely. And in that moment, the commander is instantly forced into this reactive spiral that just eats up all of their available mental energy, instead of visualizing the enemy's defeat, playing that strategic chess match.
They're managing the clock.
They're managing the clock. And they're scrambling to fix comms gaps, desperately trying to manage a fuel crisis for a unit that moved faster than planned, or constantly deconflicting airspace because their static time-based plans went out the window the second the first shot was fired.
It's just constant friction.
Ceaseless friction. And that is what digital orchestration seeks to completely eliminate, to restore the commander's focus to the true art of asymmetric violence.
Okay, so that sets the stage for the big proposal, the shift away from managing time to managing conditions.
Exactly. To restore that art, we have to fundamentally shift the entire paradigm away from time-based planning and towards condition-based execution. We execute not because the watch says so, but because the data confirms that the science of the maneuver is valid.
And this is where that SpaceX analogy comes in.
It's the key analogy for grasping the level of rigor we're talking about.
I really appreciate this comparison because it immediately clarifies what you mean by scientific rigor. SpaceX doesn't launch a multi-billion-dollar rocket because the flight director has a good feeling about the weather.
Not a chance.
They launch because the system gives them a green light.
Absolutely. Think about the technical depth that goes into a successful orbital launch. It's all based on thousands of sensors, telemetry systems, and algorithms confirming down to the millisecond that the science is valid. If a launch is scheduled for T-0 and a single sensor detects that a critical liquid oxygen valve pressure is off by just a tiny fraction,
The system doesn't ask for permission.
it doesn't. The algorithm automatically triggers a scrub. It delays the launch. It has veto power.
So the system itself has inherent veto power over the schedule, and that's based purely on scientific validity.
It creates this crucial, non-negotiable division of labor. The autonomous system handles the science. Is the rocket structure sound? Is the fuel mixture stable? Is the wind shear within the acceptable limits? This automation frees up the human flight director to focus purely on the art. Should we go?
Based on all the external factors.
All the things the machine can't judge. It might involve whether waiting a day aligns with a critical satellite deployment window or some geopolitical objective.
Well,
But that judgment call is made on a foundation of absolute scientific certainty.
they know they aren't gambling with the physics of the rocket.
They aren't gambling. So in that world, the commander, the flight director, is focused entirely on mission intent while the machine handles the mechanical reality. They're guaranteed that every single piece of the system is operating optimally.
Okay, so let's apply that. Let's take this SpaceX Standard and the idea of the scrub and apply it to military maneuver.
This is where digital orchestration provides the commander with a real-time objective go-no-go status for any planned action.
And it's based on hard data, not hope or an old paper map.
Right. It completely revolutionizes how you plan and execute. Let's go back to the source's main example, a complex converging attack. This operation requires coordinated land maneuver, precise air support that has a really tight window to operate in, and at the same time, the execution of a critical cyber effect to disrupt the enemy's command and control.
Okay, so in the current crude system, if the cyber team hits a wall, some unexpected resistance, the land and air units might not even find out until it's way too late.
Or they just proceed based on the old H-hour, just hoping cyber effect will, eventually kick in.
They're gambling on the science.
They're gambling. Under digital orchestration, that gamble is completely eliminated. The logic is enforced by data integration. So if that cyber effect gets delayed, maybe because of unexpected enemy network defenses plus some heavy EMS interference, the system instantly flags that specific scientific failure.
It doesn't just say problem, it quantifies it.
It quantifies it. It projects an impact assessment on the whole operation, something like cyber effect success probability, now 10%. Projected kinetic failure rate of proceeding, 65%.
And that's the moment. That's where the commander's art is truly liberated because they're finally being given the objective truth.
Yes, the science provides the truth. Your current plan's chance of success is now critically low. The commander then gets to exercise their art. They look at the risk profile provided by that quantified data. Do they accept that 65% failure risk and attack anyway? Maybe they'll rely on sheer surprise or superior training to make up for the lack of cyber support.
Or do they shift the whole thing to the right?
Or do they shift the entire operation to the right and the system automatically gives them a resequenced plan that waits for all the scientific conditions to align perfectly?
The decision is transformed from what was a desperate, high-stakes gamble into a calculated choice with known parameters.
That's the core of it. The science provides the quantified risk and readiness truth. The commander provides the necessary, uniquely human judgment. They are no longer consumed by trying to verify if the fuel truck showed up or if the jamming frequency is clear. They're focused solely on how the enemy will react and the strategic implications of accepting a known risk. That is true command.
But that level of artistic freedom, that ability to do condition-based execution,
Yeah,
it's just impossible if the commander is flying blind.
totally impossible.
If they're relying on status reports that are hours, maybe even days old. To get the scientific certainty, you have to switch from gut instinct to telemetrics, raw data from every single thing at the tactical edge.
This brings us to the technical architecture. We have to look at the nouns of the battlefield.
And the foundational mandate here is huge. It says every single noun on the battlefield must become a sensor and a data generator.
It's expansive, but it's necessary. We're talking about connecting individual weapon systems, vehicles, supply caches, maybe even individual soldiers with smart sensors in their uniforms.
All of it.
All of it into one massive, cohesive sensor network, the Military Internet of Things, or MIoT.
This is a fundamental revolution for logistics. We're moving away from relying on, quarterly inventory reports or daily radio check-ins?
Which are always wrong.
Always wrong and always late. We're moving to minute-by-minute, real-time tracking.
It shifts operational readiness from a best guess estimate to a verifiable scientific certainty. You get what the sources call granular logistics. Think about a mechanized brigade. Instead of just estimating fuel based on historical movement rates from some chart,
You're seeing the actual fuel burn right now.
you're seeing real-time fuel burn rates, oil pressure, and ammunition expenditures on every single vehicle. And that telemetry instantly feeds into the probability of success for any given maneuver. If Unit X needs to travel 100 kilometers, the system knows, based on the current terrain and vehicle load, that they will arrive with exactly 10% fuel remaining, and it automatically flags that as a high risk.
And it's not just for things that move or shoot. This changes how you even think about maintenance, right? It shifts from a time-based schedule to a condition-based need.
That's the real power of preventative maintenance. Imagine you have sensors reporting real-time barrel erosion on an artillery piece, or excessive RPM stress on a helicopter rotor. Right now, a commander might commit that asset to a deep penetration mission, knowing only that the vehicle should be operational according to its maintenance schedule.
A piece of paper.
A piece of paper. With MIoT, that commander knows the projected mean time to mechanical failure down to a very narrow margin of error. This high-fidelity network just removes that physical fog of readiness.
So the commander's mind isn't distracted by worrying if their equipment is going to break down halfway to the objective.
Exactly. But here's the massive technical hurdle the sources point out. If every tank, rifle, and drone is transmitting raw data all the time,
You'd just create a data tidal wave. You'd crash the whole network.
you'd drown the command post in useless information. Collecting the data isn't enough. It's useless if it just creates noise.
So you need processing power out on the network itself.
Exactly. It's not enough to collect data. It must be processed where it's generated, at the edge, to be actionable in real time. This is edge compute. You have onboard processors right there on the vehicle, on the weapon system, tasked with chewing that raw data locally. They take in thousands of data points on engine temp, fuel levels, comm status, and they transform that noise into a concise, actionable piece of intelligence.
So the network isn't transmitting raw voltage readings from a sensor. It's transmitting aggregated insights.
That's the crucial step. It's how you manage cognitive load. The commander doesn't need to see the raw telemetry from thousands of sensors. That would cause paralysis. They need the synthesized conclusion. The edge compute system analyzes all the inputs, cross-references them against the mission demands, and then transmits a simple, clear message. Alpha Company combat effective, 85%. Limitation, fuel range risk, 15%.
Instant situational awareness without the information overload.
It turns terabytes of noise into 3 key actionable metrics. And this real-time, low-latency synthesis is essential for condition-based execution. The moment a critical variable changes, say an enemy jammer suddenly degrades 20% of the unit's comms, the edge compute generates a new insight, pushes it to the commander, and triggers a scrub notification across the entire operational plan instantly.
And this technical foundation also gets at what is maybe the trickiest problem in modern warfare: coalition operations.
Oh, absolutely.
The sources argue that the art of coalition warfare depends on trust, but operational trust really requires shared, objective, scientific facts.
The trust based on a handshake is fragile in combat. Trust based on shared data is resilient. When you're operating with multinational partners, the inability to share sensitive but essential readiness data is a huge point of friction. Partners are often on totally different networks with different security clearances.
Right. So if a key asset, say a specialized U.S. bomber, is critical to a combined op, our British or Australian partners need to know its readiness status, not just that the plan says it'll be there at H hour.
They need the science. But if that readiness data is classified at a high level because it might reveal sensor capabilities or something,
How do you share it?
that's where the secure data, but unclassified SBU backbone comes in. The SBU layer is a dedicated data pipe designed for this shared scientific reality. By separating the readiness metrics, the fuel levels, the maintenance status, the current EMS interference, from the highly classified operational details, we can allow partners to see the scientific foundation of the plan without compromising security.
Okay, let's use a specific example to make that clear for everyone listening.
Sure. Imagine a joint operation. You have a Canadian mechanized infantry unit, and they are totally reliant on a U.S. resupply convoy that's carrying specialized fuel cells they need. Under the current system, the Canadian commander might only know the convoy's estimated time of arrival. With the SBU backbone, they can see the real-time status. U.S. Convoy 4, current location, fuel status 95%, Vehicle 3 experiencing 15% engine stress warning.
So they get the crucial data, the scientific truth, without seeing any of the classified stuff, like what the U.S. forces are targeting elsewhere.
Precisely. That SBU data allows the Canadian commander to adjust their plan or maybe send a preemptive recovery vehicle. It elevates coordination beyond hopeful doctrine into guaranteed, data-driven synchronization.
This brings us to the core argument then, the doctrinal shift. All of this tech isn't just for efficiency. It's to change how command itself is practiced.
That's the philosophical heart of it. The entire purpose of this massive technical project isn't to make war more technical. It's to apply the mathematical rigor that we currently only see in highly specialized fields like artillery to the entire maneuver fight. We automate the science specifically to liberate the commander's artistic capacity.
And that comparison to field artillery is so powerful. It really highlights the gap in rigor right now. Artillery is a hard science, and maneuver is often treated more like, well, like an improvisation.
Artillery is highly mathematical and completely unforgiving. Those professionals live by what they call the 5 requirements for accurate predicted fire. They follow these steps with incredible rigor, not to be robotic, but because they have to guarantee scientifically that when they pull the lanyard, that round goes exactly where they intend.
They eliminate the variables first.
You eliminate the variables of ballistics, propellant temperature, air density, wind drift. They do it all through strict scientific procedure before they commit the round.
And the critique in the sources is that maneuver forces today operate with a level of uncertainty that no professional artillery battery would ever tolerate.
Not for a second. If an artillery crew just guessed about propellant temperature, they'd risk mission failure or, worse, catastrophic friendly fire. Yet, maneuver commanders are constantly forced to guess about the fuel status of their lead elements or the EMS interference or the precise readiness of their oar support. By applying that same artillery rigor to the entire combined arms maneuver, we restore the scientific certainty needed for high-level command creativity.
You replace guesswork with quantified risk assessment.
That's it.
Okay, so let's walk through these 5 proposed requirements for accurate predicted maneuver. And let's stress that division between the science providing the data and the art making the decision.
Let's do it. Requirement number 1 is high-fidelity target location. The target. The science here is providing real-time intelligence preparation of the battlefield, the IPB, and it's derived directly from that pervasive MIoT data layer. This isn't a static satellite photo from yesterday. It's dynamic. It's continuous telemetry on enemy movement, their density, and their combat effective rates. The science gives the commander the absolute, verifiable truth of where the enemy is and how strong they are.
So the data tells you the objective truth about the target. The art is how you choose to exploit that truth.
Precisely. The art tells the commander how to approach that location. Do they bypass the flank? Do they feign a retreat to draw the enemy out? Do they attack through terrain that's technically riskier but psychologically devastating? The art is the strategy, informed by the scientific location.
Okay, requirement 2. Precise blue force location, the gun. Knowing exactly where you are.
And this has to be exact position, navigation, and timing PNT data for every friendly unit. If the system is going to run an automated scrub, it needs guaranteed, verified accuracy. The science tells us, with precision, where we are in relation to the enemy, the objective, and all our supporting units.
And the art, then, is exploiting that perfect positioning.
Yes, the art tells the commander how to use the terrain based on that quantified location. If the system guarantees you're perfectly positioned on the military crest of a hill, the art is how you use the geometry of that advantage to maximize surprise, knowing your P&T is guaranteed.
Requirement 3. Algorithmic logistics readiness, the propellant. And this feels like the biggest point of friction that the science can solve.
This is huge. This demands real-time, quantified energy and ammo status delivered straight from the MIoT. The system knows the projected distance, the current fuel burn, the available ordnance, the battery life on critical comms gear. The science tells us with near total certainty if we can get there and if we have what it takes to fight once we arrive. This data removes the biggest logistical anxiety that plagues command right now.
Which means the commander is focused purely on the strategic cost-benefit.
The art becomes deciding if the calculated investment measured in quantified fuel, ammo, and time is worth the objective. It removes the guesswork about endurance and turns the commander's choice into a measured, strategic calculation. They can focus on the enemy's morale, not their own fuel gauges.
Requirement 4 is the modern battlefield challenge, environmental awareness, the MET. And this isn't just about atmospheric pressure anymore.
No, this is crucial. This is the measurement of cyber and EMS weather. We're talking jamming levels, real-time spectrum availability, electronic warfare activity. The science here is measuring the intensity and location of interference in real time and predicting its effect on comms and sensors. This variable, if it's unknown, is the biggest driver of the fog of war today.
So the science diagnoses the digital environment, and the art decides how to navigate through it.
Exactly. If the algorithm reports a 90% probability of comms failure in a certain corridor because of jamming, the commander's art is choosing an alternate communication dark maneuver or deciding to push through relying solely on pre-planned actions. The art is how you fight through the scientifically identified challenges.
And that brings us to the final requirement, number 5, the computational procedure, the firing solution. This is where it all comes together.
This is the edge algorithms, calculating the quantified probability of success given all the current scientific conditions: the target, the gun, the propellant, and the weather. The science calculates the exact, statistically verified probability of success for a given plan based on guaranteed readiness and enemy strength. This is where the art of war meets predictive analytics.
And the ultimate art, the final act of command, that remains human.
That remains human. The art is the decision to pull the trigger, to initiate the maneuver. The commander is no longer struggling to synthesize contradictory reports or manage logistics. They're simply providing the human acceptance of a meticulously calculated risk profile.
They're signing off on the math.
They're signing off on the math and dedicating their entire cognitive focus to the human elements of command courage, surprise, adaptation.
When you lay it out like that, the contrast is just, it's so stark. The commander today is juggling spreadsheets and radio logs. The commander in this new environment is purely focused on the enemy.
The ultimate outcome is a liberation of mental capacity. When the science handles all the physical friction, all the coordination gaps, all the quantifiable variables that currently eat up most of a commander's brain power, the commander is truly free to be an artist of maneuver. They can see the enemy, know their own capacity, and decide how to apply violence without that paralyzing fear of an empty gas tank or a failed comms link.
So with that science secured, with that cognitive bandwidth freed up, the commander isn't just making better, faster decisions. They're enabled to do something totally different. They can employ the high art of irregular warfare patience, timing, asymmetry, but with heavy conventional forces. This is the ultimate goal, what the sources call guerrilla warfare at scale.
That is the ultimate artistic expression unlocked by technical mastery. Guerrilla warfare is a high art form of conflict because it requires such precise timing and exploiting momentary advantages. Historically, conventional forces, just burdened by the physics of their own heavy, slow formations, have really struggled to replicate this art form. They're just too heavy.
They suffer from what we talked about earlier, permanent density.
Correct. The friction of logistics forces them into permanent density. They move slowly, they concentrate their mass for defense, and once they're found, they're incredibly vulnerable to modern long-range fires because their location becomes predictable and static. Their own mass prevents maneuver art.
But digital orchestration allows them to break free of that predictable clumping, and it offers a new way to maneuver that dictates the rhythm of the battle. It's a 4-step cycle, and it begins with disperse.
Yes. Forces remain low density, spread out across the whole area of operations. This distribution is their protection. It protects them from enemy massed fires. And crucially, The science, the guaranteed PNT, the real-time logistics, the MIoT sensors, ensures these distributed units are fully sustained and visible to the commander, even when they're physically separated. The enemy can't find a center of gravity to hit because the force is scientifically sustained while dispersed.
Next step is the rapid convergence. Converge.
Using that data-driven SpaceX Standard synchronization, units converge precisely on a single decisive point. All the components, air, land, cyber, logistics, they all hit their required condition at the exact same moment. That data guarantee removes the risk of one unit showing up early and getting wiped out.
The convergence is purely condition-based.
Then comes the moment of violence. Strike. This is where you generate transient mass.
This is the artistic, overwhelming application of violence. Because the science guaranteed their readiness and their convergence, they hit the enemy with decisive, coordinated force, exactly when and where it's needed, achieving massive local superiority. And it's transient because that density is fleeting. It's dictated by scientific timing. They are only dense for the short duration of the destructive fight.
And finally, the step that ensures they survive to do it again. Disperse. They vanish. They immediately break contact and use that same data synchronization to flow back into those low-density distributed formations. This prevents the enemy from counter-targeting or concentrating their own forces in response. This ability to instantly transition from low-density sustainability to overwhelming mass and then back again. That is the high art of maneuver warfare, enabled entirely by data certainty.
And when a force can execute that cycle, disperse, converge, strike, disperse, and do it reliably because the science guarantees it'll work, they seize the initiative. They dictate the terms.
Absolutely. This capability fundamentally changes the relationship. Instead of being forced to react to the enemy's timeline or their initiative, which is the current state of things, the joint force proactively dictates the rhythm of the battle. They choose when and where to fight, based on their own internal scientific readiness, maximizing surprise and lethality. The system handles the logistics, which allows the commander's art to define the tempo.
So, to wrap this all up,
To synthesize the whole journey we've taken here, the central conclusion of the sources is, well, it's unmistakable. The time for relying on gut instinct, for logistics, for maintenance, for spectrum availability, it's over. Relying on intuition for these physical, measurable variables in the 21st century isn't art. It's negligence.
we've really established how digital orchestration automates that hard science, making sure the planes have fuel, the cyber effects are active, the troops are synced up, and by doing so, it clears the canvas of that old fog of war. By mastering the measurables, you remove the technical friction, and you restore the ability for real strategic genius to actually flourish.
This systemic change moves the commander out of the cockpit of coordination, and it places them firmly back into the chair of strategic, high-level judgment. The art of war is only possible when the science of war is guaranteed.
Well, we want to thank you for joining us on this deep dive into the integration of data and doctrine, and we want to leave you with one final provocative thought, something for you to think about as you consider the future of command. If the probability of success for any given maneuver is calculated and quantified by an algorithm, if the science provides the rigorous mathematical risk profile, and the commander's task is merely that final choice, the art, does digital orchestration fundamentally shift the ethical weight of military command? Does it move that burden away from logistical oversight and towards pure calculated risk acceptance? What does it truly mean when the decision to pull the trigger is effectively the last human choice in a long chain of otherwise automated, guaranteed science? Think about that tension between data certainty and human consequence.